This topic is empirical formula by combustion analysis. This is an honors level topic only. So just a reminder, empirical formula, remember, is the lowest whole number ratio of elements in a compound. And this is done by combustion analysis. And combustion analysis is actually a very valuable tool when you're trying to figure out what this unknown substance is. What they do is they combust the organic compound, because it's usually organic, in the presence of oxygen to create carbon dioxide and water and probably some other things. And they measure the amount of carbon dioxide and water that they get in order to find out what it is that they have. So it uses the general format that any hydrocarbon, which is a compound that contains carbon and hydrogen and possibly other things, when combusted in oxygen, when it creates carbon dioxide and water, all of the carbon in the carbon dioxide came from the carbon in the hydrocarbon, and all of the hydrogen also came from the hydrocarbon, such that however many moles of carbon dioxide make is the subscript of my compound for C, and half of the moles of water that I make will be the subscript for my hydrogen. So the example is carbon and hydrogen only. So I have 3 grams of a hydrocarbon and it's combusted in excess oxygen. The excess oxygen is just to make sure that I'm creating carbon dioxide and not carbon monoxide. So I create 8.8 grams of carbon dioxide and 5.4 grams of H2O. What is the empirical formula? So the first step is to convert grams of carbon to moles of carbon and grams of water to moles of hydrogen. So I have 8.8 grams of carbon dioxide. I divide by the molar mass. And then for every mole of carbon dioxide, I create 1 mole of carbon. So 8.8 grams of carbon dioxide represent 0.2 moles of carbon. 5.4 grams of water represent 0.6 moles of hydrogen. Once I have this, I divide by the lowest number. 0.2 is less than 0.6, so I'm dividing my moles by 0.2, and I end up with 1 mole of carbon to 3 moles of hydrogen. So my empirical formula is CH3. So again, I convert all my grams to moles of either carbon and hydrogen. I divide by the lowest number, and I get my empirical formula. Example 2, a little more complicated. I have a sample that contains carbon, hydrogen, and oxygen. So what's important to understand is that I can't simply say that if I have carbon, hydrogen, and oxygen, when I combust it, I could just use the law, the conservation of mass, that whatever mass is oxygen on this side is the amount of oxygen that I would have, because the oxygen here is a combination, in this case, of my CHO, the oxygen in my compound, and the oxygen that I use to combust it. So I have to do a couple more steps. So the example is 2.125 grams of a compound containing carbon, hydrogen, and oxygen is combusted in excess oxygen gas, creating 4.4 grams of carbon dioxide, 1.125 grams of water. What is the empirical formula? So first step, I convert grams of carbon dioxide to grams of carbon and grams of water to grams of hydrogen. I'm really just using percent composition here. So there's 12 grams of carbon and 44 grams of carbon dioxide and 2 grams of hydrogen and 18 grams of water. So I get 1.2 grams of carbon and 0.125 grams of hydrogen. Then what I do is I subtract the amount of carbon and hydrogen that was in my compound from the total mass to get the amount of mass in my compound that is oxygen. So if from the 2.125 grams of that I had in my original compound, 1.2 grams of it is carbon and 0.125 grams is hydrogen, that means that the remainder, or 0.8 grams of oxygen, is what makes up the rest of the mass. Then what I do is I convert everything to moles using their molar masses. So 1.2 grams of carbon is equal to 0.1 moles of carbon. 0.125 grams of hydrogen is equal to 0.125 moles of H, and 0.8 grams of oxygen is equal to 0.005 moles of H. Then I divide by the lowest number. So the smallest number is 0.05 because that's less than 0.5 and 0.12. So I divide by 0.05 on both sides for all of these. So 0.1 divided by 0.05 is equal to 2. This is 0.125 divided by 0.05 is equal to 2.5, and 0.05 divided by 0.05 is equal to 1. So this is one of those cases where I'm like, oh, I have everything where I have the lowest number is 1, and these are not whole numbers. This ends in 0.5. I multiply everything through by 2. So instead of a 1 to 2.5 to 2 ratio, I have a 2 to 5 to 4 ratio. So my empirical formula is C4H5O2. So things can get more complicated, but really not that much more complicated. If I have something containing nitrogen, I'll probably follow the same rule. But the idea is to make sure that whatever grams I get, I always convert to moles, and then I get the lowest whole number ratio. And grams of carbon is all going to come just from my carbon dioxide, and grams of hydrogen will always come from just my water.